So linear function is a straight line, and we also explored parabola, which gives you the typical the U shape, right? And then now we are exploring exponential function. Okay. And the exponential function has so this type of a shape. It starts out with a kind of flat, but then it grows and then it kind of shoots up, right? So that's an exponential function. And we are going to talk about exponential function, exponential growth pattern, okay? And let me give you, and it has a lots of applicability in our daily life. And so one example will be the rabbits. Yeah, who has rabbits? Actually, it's a funny, well, I don't know if you call this funny. I had a friend who had rabbits, and it wasn't for the pets, but it was for, consumption to eat. So I don't know. Does anybody? I do have chickens. I do have chickens, but not the rabbits. Yeah, you have two. You had it. So what happened? Yeah. Anyway, so let's say, well, again, just before we backtrack that, we have exponential function in a form of y equals, oh no, yeah. So y equals a times b to the x power. And we did talk about that a little bit yesterday. Hey, Jacob, it's good to see you. Let's see. So we did talk about that yesterday. And so here it is, right? And it's the same thing. We have, so let me show you today's notes. A represents the starting number, or we use the word initial value. Whatever the number you start with. In this case, example one, it's a 50. It's a 50 rabbits. So A, 50 is going to go into A. Okay. B is a multiplier, or often we call that rate. Okay. Rate of increase or decrease. And we will talk about decreasing exponential function, exponential, and we call that exponential decay. We're going to talk about that tomorrow, okay? But we're talking about exponential growth, and then x is the time, okay? How long? Or how many times? And that's what that x is going to be, okay? So let's actually figure out, okay? Basically, A is pretty easy. A is going to be 50, right? And then the x, the exponent, is going to be, well, like, for example, 15 weeks, we're going to put 15 into x, right? But the big challenge for right now is, what do we put for the rate, multiplier, rate of increase? for B. And let's figure out what to put in for B, okay? Now to do that, let me show you a table. Week 0, week 1, week 2, week 3, week 4, and so on. Yeah, very good. You're on to something there, Gentry. That's right. Definitely, it has to do with the 7%, right? Increasing rate is 7%. Okay, but not exactly just 0.07. Okay, but we'll figure it out. Now, but let's just figure out just week by week. At week 0, we have 50 rabbits, right? Now, after 1 week with a 7% increase, how many rabbits are we going to have? It's got to be more than that, more than 50, isn't it? But exactly how many? 3.5 more rabbits? Yeah, Gentry, how did you get 3.5 more rabbits? Anybody? Very good. Then got 7. Divide by 2. Very good. Very smart. Very smart. Very good. Now, there is a way to figure out, I mean, how do you figure out like a percentage of something? Are you guys good with that kind of stuff? How do you figure out, let's say you go to the restaurant, 15%, 15%, you want to leave 15% of a tip. I guess there are different ways to do this, but, or how about let's say 12%, 13% of something? What would you do? There's a very easy way. I'm going to teach you, okay? To figure out the percentage of something, like a 7% of 50 rabbits, right? You multiply the percentage, okay? Now, but before you multiply that, you can't just multiply 7 because 7 is in percentage. But we have to change percentage into decimal form, okay? And to do that, what is a 7% in decimal form? Does anybody know? 7% of the decimal form is 0.07. Now, if you don't know how to do it, figure it out. It's really easy. You're going to divide that percentage by 100. 7 divided by 100 is 0.07. And then that number, you multiply that to 50. So you go 50 times 0.07. So everybody take out your calculator and do this for me. 50 times 0.07 is, you get 3.5. I know we don't have half of a rabbit, but we're talking about more of a statistic standpoint of view. So let's just leave it as a decimal. So you're going to have a 3.5 more rabbit at the end of first week. So it will be 53.5. Okay? Does that make sense? Now, how about this at the end of the second week? Do you think we are just going to have a 3.5 rabbit every week more? So it will be 57 rabbits. What do you guys think? if we are adding 3.5, 3.5 every week, actually it is going to be linear function. But this is not linear function, is it? It is a exponential function. So we are not, why are we not adding 3.5 rabbits every week? I mean, how do you figure out the week 2 over here? The reason why we are not just adding 3.5 is because you have a 7% increase, right? Now, that means you are going to have 7% of not just 50, but this time to figure out second week, you're going to have a 7% of now 53.5 rabbit. Does that make sense? That's going to be a little bit more than 3.5. So if you have 53.5 times 0.07, what do we get? You're going to get 3.745 rabbit more. So you're going to have not just 3.5 rabbit more, but you got a little bit more than that than before. Very good, Francisco. We're getting to that. And Francisco is on to something here there. Because we are not adding the same amount every time. That would be a linear function, but we are multiplying. So my next question is, and Francisco already answered this question, what is there any way to go from 50 to 53.5 directly? What can we multiply to 50 to get to 53.5? And the answer is, it is 1.07. Let's try that. Let's do 50 times 1.07 is going to be, can somebody take out your calculator and do that? What do you get? It is 53.5. In other words, I don't know if I did a good job of it, but I was trying to get at is that 1.07 is going to be the multiplier. Okay. So to express the other equation, it's going to be y equals 50, that's the initial value, 1.07, that's a multiplier, to the x power. And that will be the equation. Now I'm going to go over one more time and give you the step-by-step the method of figuring out 1.07, okay? So that will be the equation. And then if you want to figure out, let's say 15 weeks, so how many rabbits do you think we will have after 15 weeks? Actually, what do you guys think? Just your guess. How many rabbits do you think we will have after 15 weeks? Over 100, 200? Well, let's figure out. So it will be 50 times 1.07 to the 15th power. And let's do that. So everybody take out your calculator. Oh, he's waiting to get in. $130. Let's do that as a whole number. 138 rabbits. Yeah. By the way, I forgot to talk about this important part of 1.07. Now, as you know, this 0.07, that's 7%, right? Now, why do we add 1 in front of it? What does that 1 do? What is that 1 doing there? Where did that come from? Yeah, in terms of percentage, what does that 1 represent? If that 0.07, this 0.07, that's a 7%. What is that 1 doing there? In terms of percentage, what does a 1 represent? Isn't 1 100%? Right? And then 0.07 is the 7%. Because if you do 50 times 1, meaning 100%, what's 100% of 50? Well, 50 times 1 is, you get 50, isn't it? Right? So if you multiply 1, you just get all 100% back. Okay? 100% of 50 is 50, isn't it? You have all 100% of 50 candies, 50 rabbits, and that's a 50, right? But you are not just interested in 50 rabbits, but you have 7% more than that 100%. So it is going to be 1.07. Yeah, very good. Excellent. So I don't know. I hope that makes some sense to you. Let's go through the assignment, okay? So here it is. You don't need to write down word by word, but let's write down enough of information to get going, okay? So first, please write down homework 3.2, exponential growth, okay? And then number 1. So what is it? It's the nest of ants. Okay, so initial value is 500. A nest of ants initially contains 500 individuals. Okay, the population is increasing 12% each week. Okay, so let's figure out the equation. Okay, I guess we need to figure out equation first. Okay, so it's going to be y equals so A is the initial value. In this case, it's 500 ants, right? And then the rate is 12%, okay? So there's an easy step to do, figure out, okay? So this is how you do this, okay? To figure out the rate or the B value, 2 steps. First, you're going to divide by 100. So you're going to do, okay, let's do this. 12 divided by 100. And what does that give you? You will get 0.12. You just changed 12% into decimal form, which is 0.12. And then you're going to add 1 in front of it. So it will be 1.12. And that will be the multiplier. This is the multiplier. Again, just to recap, to figure out the multiplier, you just need to do 2 things. So you find the percentage, right? It's always, you will always see that in the problem. It's 12% increase. So first step is to divide that 12% by 100, and you get 0.12, and then you add 1 in front of it. And so that will be the multiplier. The multiplier will be 1.12 and to the x power. This is the equation, okay? Now we can figure out after 10 weeks, how many ants are we going to have? Let's figure out. So it will be y equals 500 times 1.12 to the 10th power, okay? Because we want to figure out 10 weeks later. And what do we get? Do you guys have a good working calculator to do the exponent? If you are using your cell phone calculator like this one, is anybody doing that? It's a little bit always tricky if you use this type of a calculator. How do I do this? 500 times, can we do 1.12? Where is the exponent button there? Okay, so if you are using like a cell phone calculator, the exponent button is on the second row around the middle. You see this x to the y button? That's the exponent button. So this is how you do. Okay, you type exactly, you see it, 500 times 1.12, and then to the x to the y button to the 10th power, and then equal. Why don't you try that? What do you get? You should get 1,550. Let's do 53 ants. Yeah. Did everybody get that? Okay, very good. Are you getting that? Let's try 20 weeks. How many ants do you think we will have? So why don't you try that? So it will be, again, same thing, 500 times 1.12. This time it's 20th week, okay? 20th power. Somebody's waiting to get in. Yeah, it will be 4,823 ants. Yeah, very good. You've got it, Hope. Let's try another one. Okay, we'll just keep going. Okay. So, a herd of 32 deer is to be left unchecked on a large island off the coast. Estimated that the size of the herd will increase 18% a year. Okay. So 18% increase. Oh, you know what? I don't think I published it yet. Aiden, thank you for asking that. Hey guys, I forgot to publish the assignment. I will do that at the end, okay? Actually, let me check. Yeah, I forgot to do that. Dang it. So, no, it hasn't been published yet, but I will do that right away. There are only, let's see, 5 questions, okay? That's it. So let's keep going, guys, okay? Maybe some of you would like to go ahead and do that, but so why don't you try? I'll give you a minute. Can you come up with the equation first? Okay, and then let's figure out 5 years and 10 years.違うよ、持ってったらいいよ。売るもの？うん。タッコが出したんじゃないの？違う。いつさ、あれしたものを向こうに出したら。いや、なんだろう。ディスプレイに使おうかな。Assignment points. Okay, I just published the assignment, so you should see unit 3 now. Okay, let's figure out, okay? So let's take care of the multiplier first. 18%. So what do? You just need to do 2 things, okay? First, you divide 18% by 100. And what do you get? You get 0.18. And then what's the second thing that you need to do? You need to add 1. So it will be 1.18. This will be the multiplier. So let's form the equation. Okay. So y equals initial value, that's 32. And then multiplier is 1.18. And to the time, 5th power. Okay. So let's figure out. 32 times 1.18 to the 5th power. What do you get? 73 deer. Pretty good. No, you don't need to copy the words. Just let's jump right into the equation, okay? Maybe you can just write down like a 32 deers, 18% increasing each year, right? And that's all you need. You can write that. And then let's do the 10-year, okay? So y equals, again, the initial value is 32. Multiplier is 1.18 to the 10th power, because we want to figure out 10 years later. So 32 times 1.18 to the 10th power. What do you get? Very good, thank you. 167 deers. Deer, I guess. Is it plural form of deer? Is it deer, two, three deer, or do you say deers? I don't think you do, right? I don't know. Now, here is the financial portion of it. We will talk about this a little bit more after we come back, but here's a simple application of it. So you've got, let's say, $10,000, and you're going to leave it in the bank or some sort of a financial institution, and they will say, we will give you 6% interest every year. Okay. And let's say you're going to leave it for 10 years. How much will you end up having after 10 years? Okay. So that's what the question is. Okay. But again, just think of 10,000 as 10,000 ants, if that makes it a little easier, right? It's the same thing. You have a 10,000 ants, it's increasing 6% every year. Okay. It just became, ants became a dollar sign. Okay. And so let's go through this. So first step, I'm going to let you guys work on it first, all by yourself. Okay. So convert 6% into a multiplier form. How would you do that? You need to do two things. And then I want you to form the equation and then figure out 10 years later value. I'm sorry. You should scold me for texting. Somebody texted me something important. Sorry. Okay, let's. Yeah. Okay, let's figure out. So first, 6%. We need to treat 6% so that we can use that into the equation. First, we have to divide by 100. And you get 0.06, okay? And then you're going to add 1. So it will be 1.06. Is everybody okay on that? Okay, that's not too bad, right? And now let's form the equation. Again, for those who just who came in, exponential function takes this form, y equals a times b to the x power. A represents the initial value, okay? And you can look up the notes from yesterday and the beginning of today's notes when you watch the video, okay? So A is going to be 10,000 because that's the initial value. And then B represents the multiplier, which is 1.06. And then X is the time. And in this case, it is 10. Okay, so let's figure out. I hope already figured it out. Thank you. I want to do that too. 10 times 1.06 to the 10th power. That's really the power of investment here. I don't know if you're interested in this kind of stuff. You know, without you working, doing anything, if you can find 6% of interest, the place that will give you 6% interest, which is rather high, by the way, but you know, without doing anything, you almost doubled the money, right? Without you working, the money is not working for you, right? So, and I hope you, I don't know, talk to your parents. Maybe your parents are preparing for retirement. Maybe they do some investments. You can talk to them about that. Yeah. Or even they're not, maybe you can find out more about it, right? How, I mean, probably the retirement is the last thing that you will be thinking about right now, right? But, you know, the earlier you start to prepare for retirement, the better it gets, okay? You don't want to get started on a retirement at the age of 40, 50. The earlier, the better. And anyway, maybe we can talk about that a little bit more later. Okay, number 4. So why don't you try that all by yourself? Number 4. There are 2 more questions to go. Okay, number 4 and number 5. And then we're done. That L-shaped symbol, that's a pound, British money. Louisa invests 15,000 pounds into an account that pays 8%. Again, 8% is really high for normal regular bank nowadays, but you can actually achieve 8% with a stock investment. Typically, I do have some personal investment on a stock mutual fund. It's called mutual fund. And in average, okay, there are some good years There were some bad years, but over time, it has paid about 8 to 10% interest. Yeah. Okay, so what do you do? Yeah, that's really good, right? Without you doing anything, now you've got 22,000 pounds. Let's figure out, okay? So first, you need to treat 8%. So first, you need to divide that by 100. And you get what? You get 0.08. And then what do you need to do next? You need to add 1 to it. So it will be 1.08. This will be the multiplier. So you always want to figure out the multiplier, okay? So let's figure out the equation. Y equals initial value. Initial value of investment is 15,000. And then the multiplier is 1.08. And then to the time is to the fifth power. That's the equation. Okay. And then if you do that, only just after 5 years later, it is 22039. 22,000. Okay. Not quite double, but you've got what, 7,000 pounds more. Okay, last question. Again, just same type of a question, 5,000 to begin with. The interest rate is 4.25%. Do you guys understand how bank make money? So bank collects money from you guys, right? We deposit the money, right? And what will they do? They're not just sitting there. The money is not just sitting there. The bank will use your money and they will collect it, right? And into a big pool, and then they will lend it to somebody else, your money, and they will charge people. Well, let's say Mr. Takara wants to start business, or Mr. Takara wants to buy a house, right? So you borrow money, right? When you borrow money, you have to pay in the interest to the bank, right? And then the portion of the interest that a bank collects, they will pay you back the money, right? And that's how bank will make money. So they will charge Mr. Takara, the business owner, like let's say 8% interest, right? And then that 8% interest that they collect, they will give you, let's say, 2% back to you, right? Because you're putting the money back into the bank. Right? So bank will, in return, they'll give you the interest. But if you borrow money, you have to pay the interest. Does that make sense? Yeah. Okay. So 4.25%. Now, for some reason, when you see the decimal percentage, people start to do some funny things. But you just do the same thing, okay? So even though it is a decimal, it is still a percentage right now. So you have to go through the normal procedure by dividing by 100. Okay, so you do 4.25 divide by 100, and what do you get? You get 0.0425. Is everybody okay on that? Now you add 1. So it will be 1.0425. This will be the multiplier. Do you have, or will you check your notes? Do you guys all have a 1.0425 as a multiplier? Okay, now let's figure out 5,000 times 1.0425 to the 8th power. This dollar. Is that what you have? $6,975. Very good. So this is the exponential growth pattern. Tomorrow we will do exponential decay. Decay means to go down, isn't it? It means to rot, right? It means to go down in value. And so we will talk about that tomorrow. Okay. So this is the end of the assignment. Please make sure that you take a picture of your work and not mine. Make sure you take a picture of your notes and then please turn it in. So that's all I have. If you have any questions, if you, I don't know, came in late and if you want to go over a few things, you're more than welcome to welcome to stay around. Otherwise, have a great day and I will see you guys tomorrow. Take care, guys. Yeah. So tell me when. Where do you want to see? This is the notes part. Is this where you want to see? Hope. You good? All right. Hey, thank you for your participation. I hope appreciate that. I'll see you tomorrow. Hey, everybody else, does anybody else need any help? Hey, Jacob, how are you doing? Let's stop recording.